Evolution and classification. Based on this principle, we can work out the evolutionary relationship of a species we see around. Okay, it is a sort of going backward in the time. Okay, if we go a backward, okay, we can see that in ancient time. Okay, they are talking about in a ancient time. We can do this by identifying a analysis of a characteristic between species. Okay, species. Okay, between the species, how the characteristics are identified. In order to understand this process, let us think back to our discussion on the classification of organism. Okay, similarities among organisms will allow us to group them and then study the group. For this, which characteristic decide more fundamental difference among organisms and which one decide a less basic difference? What is meant by characteristic anyway? Characteristics are the detail of appearance or behavior. In other words, a particular form of particular function. Okay. If we talk about this, then different type of species have different characteristic. Okay. All of them have its unique characteristic and which are different from other organism. Okay. So all the organism have their own characteristic and which are very differential with and which are making them different from the other organism. Okay, so all this we say it as a characteristic of a particular organism as well as species. Okay, that we have four limb is thus a characteristic. Okay, the that plant do not photosynthesis is also a characteristic. Okay, that plant can do. Okay, what the plant are doing photosynthesis, that is also one of the characteristic, and we have a four limb is thus a characteristic, that is also one of the characteristic. Okay, so all the organism have their own characteristic and depending on that we can distinguish them as a one of the species. Okay, all the species are differentiated as a one of the species by their own characteristic. Okay, with the help of their own characteristic, a different species or organism are classified as the one of the important species or organism. Okay, some basic characteristic will be shared by most organism. The cell is the basic unit of life in all organism. Okay, if we talk about the organism, then cell is the basic unit of life in all the organism. Okay, cell are very necessary. Okay, the characteristic in all the next level of classification will be said by most, but not all the organism. Okay, if we talk, a classification will said by most of them, but not all the organism. A basic characteristic of a cell design that differ among different organism. Okay, characteristics are different for different organism. Is whether the cell has a nucleus. Okay, bacterial cell do not, while the cell of a most other organism do. Okay, bacterial cell which we are talking, they are do not classified as a different category. Okay, while the cell of the most other organism do. Among organism with nucleate cell, which one are unicellular and which ones is multicellular. Okay, which one is unicellular and which one is multicellular can be judged, okay, by the nucleate cell, okay, which are present in the organism. That property mark a very basic difference in the body structure. Okay, depending on that we can judge a body structure of a particular organism by the differentiating them as a unicellular or multicellular. Okay, through which we can judge that what is the structure of that particular organism. Because of specialization of a cell type and tissue among multicellular organism, whether they can undertake photosynthesis or not will provide the next level of classification. Okay, whether it is giving a photosynthesis or not, that is also one of the important characteristic. Okay, So among the multicellular organism that cannot do photosynthesis, whether the skeleton is inside the body. Okay, now the next classification is that whether the body, or a skeleton, which are present are inside the body or around the body, will mark another fundamental design difference. Okay, that is also one of the fundamental design difference. We can see that even in these few questions that we have asked, a heresy is developing that allow us to make a classification group, due to which we can classify a particular group. The more characteristic two species will have in common. Okay, how two characteristic species can be common, by their more characteristic. The more closely they are related, and the more closely they are related, the more recently they will have common ancestor. Okay, if we talk about that, the related characteristic are matched, and if the related characteristic are matched, then they have a common ancestor. If we talk about that, an example will have a brother and sister are closely related. Okay, if we talk about that, one brother and sister, are having a closely related with each other characteristic. They have common ancestor in the first generation. Okay, in the first generation, you can see that they have a common ancestor before them, namely their parent. Okay, a girl and her first cousin are also related. Okay, we talk about a girl, and her first cousin. Okay, they are also having a related characteristic, but less than the girl and her brother. Okay, why? Because here you can see that its own brother or sibling, brother, have a common characteristic if we compare it with her cousin brother. Okay, so a girl having a same characteristic or related characteristic with her own or sibling brother, is much more, than her cousin brother. Okay, so from that we can see that if a sibling girl and boy are there, they have a common as well as much more related characteristic than comparing it with their cousin brother or sister. Okay, so this is because cousin have common ancestor, their grandfather. Okay, in the second generation before them, not in the first one. Okay, so it is to from second generation. Okay, from where? Okay, from his or her grandparents, not from her father. We can now appropriate that classification of a species in is in fact of reflection of their evolutionary relationship. Here you can see that frog and lizard, homologous organ. Okay, here you can see that homologous organ, birds and human. Okay, we can thus build up a small group or species with a recent common ancestor. Okay, with their depending on their common ancestor, we are specifying a small group of species. Okay, so from that also we can see that. Then supergroup of this group with a more distinct common ancestor, and so on. In theory, we can keep going backward like this until we come to notion of a single species at a very beginning of a evolutionary time. Okay, if that is case, then at some point in the history of the earth, non-living material must have given rise to the life. Okay, non-living material must be giving rise to a life. There are many theories about how this might have happened. It will be interesting to come up with the theories of our own. Okay, if we talk about this, we should follow our own characteristic as well as theory. From that we can identify our classification. Now, tracing a evolutionary relationship. When we try to follow evolutionary relationship, how do we identify the characteristic as a common? These characteristics in a different organism will be similar because they are inherited from the common ancestor. Okay, if we talk about the some of the characteristics, okay, which are there, which are what, okay, different organism have a similar characteristic. Okay, they are having a similar characteristic. Why? Because they are inheriting or getting from where? Okay, from their common ancestor. Okay, they are getting it from their common ancestor. So the both of them will get a same characteristic from their common ancestor, and due to which, okay, you can see that some of the characteristics are common, okay, with both the organism. Okay, so as an example, consider the fact that a mammal have a forelimb. Okay, mammal have what? Okay, forelimb, as do bird, reptile and amphibian. Okay, what? Okay, mammal have a forelimb like a bird, reptile, and amphibian. The basic structure of this limb is similar, though it has been modified to perform a different function in the various vertebrae. Okay, so here you can see that limb are similar, but a different vertebrate are using it for a different functioning or purpose. Okay, for different purpose, different vertebrate are using that limb. Okay, such a homologous characteristic, this is the one of the homologous characteristic, help to identify the evolutionary relationship between apparently different species. Okay, this is the homologous characteristic which are very helpful, okay, which are very helpful for relating it from a different species. Okay, for relating a different species with the another species. Okay, we can see this homologous characteristic, and depend on this homologous characteristic, okay, we can identify or judge different species for that particular characteristic. Okay, so however, all similarities simply in an organ shape are not necessary. Okay, in all the organ there is not a necessity of a shape because of a common ancestor. Okay, from the ancestor also they are getting a proper amount of. What would we think about the wings? Okay, if we think about the wings, what about that? Okay, here you can see that. Okay, bat. Okay, the wings of a bat and the wings of a bird, you can see it very well. Okay, so there is a lot of difference in both the wings. Okay, so bat, if you see a bat, okay, which are very what, okay, totally different if we compare it with the wings of a bird. Okay, so this is known as analogous organ. Okay, so bird and a bat, for example, a bird and a bat have a wings. Okay, both of them have a wings, but squirrel and lizard do not. Okay, but if we talk about the squirrel and lizard, okay, they do not have. So are a bird and a bat more closely related to each other than the squirrel or lizard? Okay, before we jump to this conclusion, let us look at the wings of a bird and bat more closely. Okay, if you can see wings of a bat and bird, okay, we do that. Okay, we find that the wings of a bat are skin fold, stretched mainly between the elongated fingers. Okay, but the wings of a bird are feathery, covering all along the arm. Okay, all along the arm you can see that bird's wings are covered by the feathering, while for the bat you can see that it is stretched by the skin fold. Okay, so an elongated finger are also present. The design of two wings, okay, their structure and component are thus very different. Okay, all of them have a different okay, characteristic, you can see it. Okay, so if we compare the bird and a bat wing, okay, they both of them are totally different with each other, and they look similar because they have a common use for flying. Okay, they are using a similar purpose. They are using a similar purpose, but their both of them contain a different structured wing. Okay, their wings are containing a different structure. Okay, so both, but their origin are not common. Okay, origin are not common. You can see that both of them have a total different characteristic, and that the wings are also different from each other. Okay, so this make them analogous characteristic. This is the one of the analogous characteristic of both of them rather than homologous characteristic. It would now be interesting to think about whether a bird arm and a bat arm should be considered a homologous and analogous. Okay, so it will be interesting. Okay, now fossils. Okay, such study of a organ structure can be done not only on the current species but also on the species that are no longer alive. Okay, that can be studied. Okay, which are currently not we are studying about currently species, but for that also which are no longer alive. How do we know that these extinct species ever existed? Okay, if we talk about the some of the species, okay, how we know that these are really existing in the ancient time or ancient period? Okay, how we know it? We know this from finding a fossil. By finding a fossil, we can see that some of the species are exited in the are exist, okay, in the ancient time. In the ancient time, okay, different species are there. If we talk about the dinosaur, okay, we are thinking or imaging as a dinosaur only, but they are existing or not in the past. Okay, we are not knowing in the ancient period it is really it is there or not. How we know? By the help of fossil. With the help of fossil, we can know that it is really existing or it is just imaginary. Okay, so what are fossil? Usually when an organism die, okay, whenever an organism are dying, that body will decompose and be lost. Okay, whenever a particular organism die, at that time what we are saying, that body will decompose and lose. Okay, and it will lose. But everyone in a while the body or at least some part may be in the environment. Okay, that body will decompose and lose, but little bit of that part are present in the environment. That does not lead it decompose completely. Okay, the fully body will not decompose, but some of the part will remain in the environment. Okay, if a dead insect get caught in a hot mud, okay, for example, okay, if a dead insect is caught in the hot mud, okay, what we are saying, for example, it will not decompose quickly. Okay, it is there in the hot mud, then it will not decompose. Okay, it will remain as it is, and the mud will eventually harden. Okay, the mud will what? Okay, it will be hardened and retain the impression of the body part of the insect. Okay, and due to which you can see that the body part of an insect or a deadly insect, okay, will remain as it is. Okay, and it will impress it, okay, when we dig it. Okay, all such preserved traces of a living organism called fossil. Okay, so such preserved traces which are there in the living organism are said to be fossil. Okay, we say it as a fossil. Okay, which are remaining traces or preserved traces which are there of a living organism are said to be fossil. Okay, now here you can see that fossil, a tree trunk, okay, as well as invertebrate which we said as ammoniate. Okay, here you can see which is one of the fossil, as well as fossil invertebrates which is trilobite. Okay, and the fish. Okay, here you can see that traces or a fossil of a species, as well as dinosaur skull. Okay, okay, so this all these things are the various kind of fossil. Okay, so how do we know how old the fossil are? Now, the second question arises that fossil which we have already find or discovered. But how we know that it is how much old? Okay, there are two components okay to this estimation. For estimating that there is a two component through which we can get a conclusion. One is relative. If we dig into the earth and start finding fossil, it is reasonable to suppose that the fossil we find closely to the surface are more recent than the fossil we find in a deeper layer. Okay, so from that we can see that if we go deeper and deeper, then it will be ancient, and if it is in a little bit deep only, then it will be near to the time. Okay, from the recent time. So the second way of dating fossil is by detecting the ratio of the different isotope of the same element in the fossil material. It will be interesting to find out exactly how this method works. How this method is working, that is also one of the important thing. Okay, by which characteristic? Okay, fossil we are getting, but how much old and what is its characteristic? That is also one of the important thing. Okay, so from that we can see that. And fossil, we know it what? Okay, preserved traces okay of a different organism okay are said to be a fossil. Okay.
Now let us learn about the classification in detail. Different types of classification of animals are given with different view. The Greek thinker called as Aristotle has classified animals based on the habitat of the animals. For example, animals living in sea includes coral, whales, octopuses, starfish and sharks. Even though they are of the same habitat, the characteristics are different. Now let us learn what is meant by evolution. The gradual process of developing body design from simple to complex, which helps the organism to survive better than the earlier one. In 1859, the scientist called Charles Darwin had described about evolution in his book called The Origin of Species.